Where is my... Oh, here it is. Here it is. One second, I will publish my YouTube. Sorry. This. Yeah, worked. 2 courses for free students. So I kept recording from previous year. You can compare my previous with my present. Okay, I don't need this, I don't need this, and this is also not needed. Okay. 0 viewer. Maybe someone will appear. And here is my blackboard. Good for theory. I'm a strange guy, I'm in some kind. I hate PowerPoint presentation.
Regarding the examination you feel, like you will give us 10 tasks.
They are already published. You can...
These 10 tasks on the bottom one, right?
Yeah.
So we have to finish...
At last 4.
Till the deadline?
Yeah. One of the basics of this work is approved. What? Things do not disappear without a trace. If you can find access point, expensive access point, try to check bit high. Found in sailing. It was circus. You lost it. No, you lost it. They took it. No. Nobody. You more. Finally, it's in sailing. Okay. What will be here? I will start from little beginning, from topological analysis of DC network. What's the meaning of topological analysis? What is it? Guy Kirchhoff, Gustav Kirchhoff's formulated two laws. Kirchhoff's current law and Kirchhoff's voltage law, yeah? Kirchhoff's current, sum of current in any node is 0, and voltage, sum of voltage drop on any closed loop is 0. Easy. It's a basic for network analysis. What means network analysis? I have voltage sources, I have current sources, I have resistance. I need to find node voltage and branch current. Yeah? Problem. All these objects are ideal. You know, in reality, we have power line, generator, and so on. Really, we will do our job. Why we need this network analysis at all? Problem. My real occupation is fault protection, fault location. I cannot ask guys from power company, guys, let me make a couple of faults. I would like to know fault currents, fault voltages. They will kill me because it's extremely expensive. I can make as much faults as I will on a model. I need a model to torture it. I would like to case my protective device. I would like to understand what to program in, how to operate, what kind of algorithm should be inside. But to work with it, I need a tool to, let's say, to get a knowledge on fault regime. What will be current, what will be voltage, how will power distributes, and so on. In real life, in 30 years, I saw 3 real tests. Take this picture. It's an artificial fault. In Lithuania, neighboring Lithuania, on 330 kilovolt substation, artificial fault was made. Nice picture. I need a let's say, model object to torture. So, between reality, real power line and so on, will be first substituted with how it works. I have real power line where faults occur. I will first derive model in terms of electrotechnics theory. From the real power line, I will derive this model. And from this model, I would like to achieve something like equation system equals to 0. Equation system describing electrotechnics theory model. From this equation system, from numerical model, in our business, it's at last 2 levels. First, models in terms of electrotechnics, with some kind of precision. For your understanding, 330 kilovolt line model, precise in phase coordinates, written on paper, this table and this table, two tables. Row of paper on these 2 tables. It's an exact model of power line. Yeah, it exists.
Can you repeat this example? Table, what did you say?
Exact precise model in terms of electrotechnics was written on a paper rows, and these rows, 1 table and second. Here it was written on a paper. And it's only half. So we need to set how to say precision level, where how precise our model will be, what can be omitted and what is necessary. For fault currents do not require high precision. You only your benchmark is some 10%. When we speak on fault location, it's another level of precision. And wave propagation may require even more precise approach. But so, faulted line, model in terms of electrotechnics theory, system of equation, numerical model. We solve numerical, we got some results, and then this result can be converted backwards to reality. Topological analysis is a way to do this part. How to derive a numerical model from the ideal network. Another step is creation of ideal electrotechnic circuit from the real line. Real transformers, real wires, real switch, and so on. Okay, let's start. Let's say I'm starting from the bottom, because I cannot speak upper parts before we understand the lower. Yeah. I will draw simple network. I don't know what this corresponds to. Something like this one. Oh, very simple network. First idea here is idea of node and branch, or branch and node idea. Node is any point in your schematics where you can measure voltage. You can take voltmeter, your voltmeter. Connect, yeah. If it's possible to measure voltage, it's a node. Branch is what? Between nodes, or topological analysis has an idea of unity branch or basic branch. It's like Lego brick. It has resistance greater than 0 and less than infinity. And it has an EMF greater or equal than 0 and less than infinity. Ideal branch. So topological analysis considered any network as a combination of branches. even branch in the air has nodes. I don't know how in your school. Here I regularly fight with one misunderstanding. This misunderstanding is difference between point and node and bus. What is point, what is node, what is bus? What is node in your notation? Node.
Any dominant? Any dominant operator?
Junction of a city.
Very popular definition is point where three or more branches are joining together. It's wrong. It's wrong. Okay. Node is any point where voltage can be measured. It's good. For me it's good. For where it is. How will we call this thing? Call this one. No? You know what this is? Circuit breaks.
Yeah.
It's three phase. I will get one. It's a set of three for each phase. It's similar for each phase. Here you can connect the circuits in one. This is it's called Kopner or in Argo Chem the comp. Do I have something what looks like small circuit breaker? I have a lot of large circuit breakers. What's the large? Because why I don't have the cheaper one? What's here? Remove one. Here they are. Stand back. Okay, I will find. Okay, wait. Strange. Why everything disappears? Everything except what I need. Lamps fixed, more lamps, connection bars, everything except. Okay. I don't know what's there. I have giant like this one. Yeah, it's a without its shelf. Quite? think it's what? No, it's only for some 300 amps.
Mm-hmm.
This one better. It's for 24 kilovolts and 600 per amps.
So vacuum circuit breaker?
SF6.
SF6. Okay.
Not. What? Yeah, full operational. If faults occur, signal came and it's disconnected. Protective device can send a recording recalls. Okay, protective device need to understand, should I send disconnect signal or not? And this will be discussed in next year. Power systems protection is on the second year. Okay, let's return to the simple thing. Simple thing is network is considered to be a combination of branches. Node, branch. Branch between nodes. Nodes on side of the branch. Node, if we speak a topological analysis, there is no difference between point and bus. So, where many circuits are connected, it's a bus. Where only two, it's a point. But for topological analysis, both are nodes. We can get voltage. Yeah, anywhere where it's attachment point. I love this circuit. How many branches do we have? 1, 2, 3, 4, 5, 6. I can connect them in series and attach voltmeter to any. So, yeah, it's a set of resistance. Something like this. 1, 2. Or I can use it as a one resistance. It's on my. What do they want? Yes. One second. I need to. I need to show where repair work should be done. 1 second. I just point this, and this. They will only mark and point. Yeah, repair. Oh.
Yeah.
But he's good in that, I guess. He will put marks, I guess.
Maybe.
He will put marks, I
If
guess.
we come regularly,
Yeah.
he will give the mark.
If he had over 70,
Maybe.
over 70% of attendance, then he will put up.
Yeah.
No need, in fact, just, if we just try all 10 and 3.5 are good, then again he will drop. On Wednesday we daily have this class only, right?
Yeah,
Wednesday are for, only for them.
Then two other subjects we have on which That's
in morning before this 12.
that's two are in online maybe.
Same time, same time.
Hmm.
And then
No,
two English lectures.
no, I don't have that
कल
subject.
तो भी था ना मैम इंग्लिश वाला हाँ तो दो वो है अपने एक उससे पहले होगी
I have only three subjects this semester.
yeah six
Yeah, I
so
studied in previous semester. English and physics and something like that. I had in മൂന്നെണ്ണം ഇതും
and we have alternate on Fridays also
yes.
from October and just October and November 2 months like 8 classes
ഇതില്ലേ ഇതിന്റെ
yeah
schedule
just
വന്നിട്ടുള്ളൂ
8 no
ഓൺലൈൻ
4 classes only 4 or 5
മൺഡേ 6:15 തൊട്ട് 9 വൈകുന്നേരം ഓൺലൈനാണ് ഓൺലൈൻ ഇത് ഓൺലൈനാണെന്ന് പറഞ്ഞു ഇതെന്തോ പവർ പ്ലാന്റ്സ് ആൻഡ് ഇലക്ട്രിക് സ്റ്റേഷൻ ഇത് ഇതിന്റെ എക്സാം ചെയ്യാൻ പ്രോബ്ലം ഒക്കെ വരുന്ന പറഞ്ഞു
when is online
then power plant and electrical stations it's online Monday 6 നിങ്ങൾക്ക്
we don't have schedule for Monday so we just have Friday Wednesday and
no, now you check.
I've checked already this was already added every time
Oh, you just check. You have the subject power plant. The subject.
yeah I found the subject but we don't have any classes on Monday so we just have classes
You just click the subject here.
I'll see in this now that's much better
No. Don't take the schedule. You check. You just take the subject. Like.
power plant and electric stations
Let's go. We have. There's no schedule because of the online.
so how do you get that we just have on Monday where it is
It's
Monday
the
18 okay
you have description.
6:15 and mostly
8:15.
like we it's written below
Hmm.
here in 319
Yeah.
or remotely
Hmm.
okay I didn't get it
And the two lectures.
so
Take
we
the
missed
same.
the last one
This is another meeting. No, 23 first class.
oh no first lesson is on 23rd of
23.
September
Yeah.
next on 30th and that's it just 2 classes and so much content rest all are included in schedule right on 23rd
കോർ സബ്ജക്റ്റും കഴിഞ്ഞിട്ടുണ്ടായിരുന്നു അതും രണ്ടെണ്ണം കോറൊരു ഇതുണ്ടായിരുന്നു മാനേജ്മെന്റ് ഇതുണ്ടായിരുന്നു പ്ലാനിങ് പിന്നെ ടെർമിനോളജി ഡയഗ്നോസിസ് ഇല്ല ഇതൊക്കെ കഴിഞ്ഞ ക്ലാസ് ക്ലാസ് ഇത് നിങ്ങൾക്കുള്ളതല്ലേ ടെർമിനോളജി ഇംഗ്ലീഷ് അത് എൻ്റെ കഴിഞ്ഞു ലാംഗ്വേജ് കഴിഞ്ഞു ടെർമിനോളജിന് 3 വന്നല്ലോ അത് നിങ്ങൾക്ക് എന്ത് ചെയ്യാറുണ്ട് പിന്നെ കഴിഞ്ഞ ഇത് ഇത്ര പിള്ളേരുണ്ടായിരുന്നു ഉള്ളത് ഞങ്ങളുടെ സബ്ജക്റ്റിൽ ഒരാൾ 3 പിള്ളേര് ഞാൻ അനൂപ് അനുഭവമുണ്ട് പിന്നെ എന്താ ഈ ഒരു സബ്ജക്റ്റ് വെച്ചിട്ട് ഒരു 10-15 പേപ്പറിലാണ് റിപ്പോർട്ട് വയ്ക്കുക ക്ലാസ് അടുത്ത ഡയഗ്നോസിസ് അതൊക്കെ കഴിഞ്ഞ് വ്യക്തമാക്കി ആ കോഴ്സ് കഴിക്കുന്നില്ല ഇതുവരെ എടുക്കില്ല കലിപ്പ് ഒരാളെയാളാ കലിപ്പല്ല ഞാൻ ഇത് ശരിയാണ് അങ്ങനെ വേറെ പ്രശ്നമൊന്നുമില്ല വെറുതെ ഈ സാധനങ്ങളൊക്കെ മറ്റേ പവർ പ്ലാന്റ് ഇല്ലേ അതില് എക്സാമിന് പ്രോബ്ലം ഉണ്ട് അന്ന് ചെയ്തിട്ടുണ്ടാവില്ല ഇവണെങ്കിൽ നാട്ടിലുള്ള ആളുകളോട് ചോദിച്ചിട്ട് ആ ടൈം എക്സാമിന്റെ ഇടയിൽ അത് അമ്മ പറഞ്ഞു വല്ലവരും അറിയുന്നുണ്ടെങ്കിൽ ഓഫീസ് വെച്ചോ അന്നേരം നാട്ടിൽ നിന്ന് വല്ലവരും കൊച്ചിനെ അത് ചെയ്ത് അത് പാസ്സാവണം നമ്മുടെ തമ്മിലൊക്കെ ആ നാട്ടിലെ പോലെ ട്രാൻസ്ഫോമറിന്റെ റേറ്റിംഗ് അത് ഇതൊക്കെ തന്നിട്ട് എന്തൊക്കെ കണ്ടുപിടിക്കുന്നു ഇവിടെ ഇങ്ങനെയൊക്കെയാണ് നമ്മുടെ നാട്ടിലെ പോലെ ഒന്നുമില്ല ഇനിയിപ്പോ ഇയാളുടെ ഇത് കണ്ടായിരുന്നു Please solve the pseudo-method equation x is equal to coefficient towards ആരില്ലെങ്കിലല്ല വരാൻ പറ്റില്ലെങ്കിൽ എനിക്ക് അവിടെ ഫുൾ ടൈമാണ് ക്ലാസ്സുണ്ട് പക്ഷെ അവർക്ക് ഫുൾ ടൈം വർക്കൊന്നും അങ്ങനെ തരില്ല പാർട്ട് ടൈം ജോബ് ആണെങ്കിൽ ഓക്കെ നമ്മുടെ ഇഷ്ടത്തിന് നമുക്ക് വർക്ക് കിട്ടും 5 ദിവസം വർക്കില്ല ഞാൻ ഉദ്ദേശിച്ചു ഇവിടെ ഈ ഇൻഡസ്ട്രീസിൽ ഫിൽറ്റർ ഉണ്ടാവും ഈ മോട്ടറിനൊക്കെ ഫിൽറ്റർ ചെയ്യും DC മോട്ടറിനൊക്കെ അങ്ങനത്തെ സാധനങ്ങൾ പിന്നെ എയർ ഫിൽറ്റേഴ്സ്
It's so nice to sell. Please repair on the central expense. Okay. Machine. If you don't like me, I will not like you. And it will be your last day. Okay. How can I analyze this network? Where should I start? I need to start from a reference point. I need to set a base somewhere. For abstract network, something somewhere may be existing. Reference point can be anywhere. It's not problem that this is network in the air. I can use any node as a reference. In reality, it's not so easy. Sometimes my reference point will be true ground, true earthing point. On other cases, bit more tricky. See that the requirement for reference point, it should have a constant voltage. Not zero, not ground, only constant. Sometimes it's more preferable to use as a reference point node, let's say output path of the powerful power plant. I will speak about it in very close future, but here at this point I can choose any node as a reference point. I will draw it green. Here is my reference point or base node. I will start with the 0 voltage. But it's only starting point. I can choose, here I can choose anyone. Real life set some constraints. What can I use as a reference point, and how I can use, how can I set this reference point? We will speak about it. When I have the reference point or base node, there are two terms, base node and slack bus. Sometimes slack bus is a reference node, sometimes no. But at this point, reference or base node. Other nodes can be numbered. Okay, I have green. 1, 2, 3. As I wish. Node numbering is absolutely free. Second, I need to number branches. And also, not only number, I need to set a branch direction. Here we will use oriented graph. So let's say this is branch 1, this is branch 2, this can be branch 3, maybe this one is branch 4, and this one is branch 5. I did it as I want. It's on my disposal. Now I can present my network topology or my network design as a matrix. See, I need all this being readable by computer. Of course, I can call AI, please take a look on my schematic. I will receive some kind of garbage. This is schematics of, following by something from Wikipedia. This should be readable to computer. A machine works, I relax. So, how can I do it? I will need to create a matrix called first matrix of incidence or nodal matrix. Row numbers will be nodes, column numbers will be branches. If node branch inflows into node, -1 should be written. If branch flows from node, 1. If there is no connection, I will write a 0. Something familiar? No? In some schools, this matrix can be marked as A or gamma. No? Nothing? Ha 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 ha. Okay, we can conduct matrix for my network. Uh, 1, 2, 3, 4, and 5, and 1, 2, and 3. First matrix of incidence. Let's do it. Yeah, one important moment. What do we see here? 1, 2, 3. But what we do not see? Base node. Base node should not be included in this matrix. If you include the base node, you will receive unsolvable system of equation. It will be singular. Be afraid of singularity. Yeah, so what I'm doing, branch number 1, in false in first node, yeah? So here I write -1 and pair of zeros. Branch number 2, from the first to number 3, yeah? So here is 1, here is -1 and 0. Where is number 3? 1, 2. -1, 1, 0. Number 4, where are you? Here is number 4, from 2 to 3, yeah? So here -1, here 1, here 0. And number 5, from 3 to base. So here 1 and 0, 0. I don't have a row for base node. I don't need it. Here is matrix representing topology of network. Branch, node, in false -1, out false 1. Who write -1 like this? Clear?
So if in branch number 4, if potential is in this direction.
If in, -1. If out, +1.
If we count 3 and 4, it's in. Yeah. And for the ground, it will be for 0 for all, right?
0. This node, we say excluded it. So there will be no row for base node. It's not. It may be ground or not ground. It's a base node.
Okay.
It's ground for theoretical, some abstract. It's ground for faults, but for power faults and tasks like this, it will be not ground, but a powerful station with voltage control.
So doesn't matter how many nodes we have, but we have to deduct the base one.
Yeah, only one should be our reference point. Okay, let's go forward. Do something. I can do something. Yeah, I will add a current source. 1, maybe 2. Okay, maybe. Like this. This will be 1. This will be 2. I will use that. What's next? AMF. Now, what about components? This topology matrix only contains information how network is connected.
What have you connected?
I have added a pair of current sources.
Okay.
Just 2. I will count them. What about AMF? There are 2 ideal energy sources in electrotechnic theory, yeah? One is AMF, where the voltage is constant, yeah? It's like giga power battery. Battery with infinite power, yeah? Constant voltage. Here I have a pair of batteries in box.
It's constant.
Constant voltage. And another one where current is constant. Constant current. Yeah?
So these are constant current sources.
Yeah. Good. These two are constant current sources. Both are ideal. I would say, imagine battery with very, very large battery. It's easier to imagine when something producing constant current. Actually, everything is possible with some limitation. Take an amplifier, take a load resistance, and use what I'm doing. Feedback. And use a load voltage as a feedback. What will we get? Constant voltage, voltage stabilizer. Maybe reference point is needed. Easy. Resistance, then a diode. Load resistance plus in. Huh? Something familiar circuit. Simple voltage stabilizer. Voltage stabilizer is a model of EMA. Yeah? Okay. Load. Add small resistance, something like 1/10 of L load. And take a feedback from this resistance. What will you get? Current source. Because feedback is by the current, not voltage. This is shunt resistance. This tiny resistor yields 75 millivolts when 1.5 kiloamps flow through it. It's for 1500 amps. Small. I saw for 1300 amps. Okay, let drivers work like this. Oh, here it is. Power supply from flat TV. Here was backlight. And this small circuit is a current source for backlight. It is regulating transistor. Looking for near current source, you can look on your PCs also backlight of displays usually is driven by current source. Okay, how can I How can I account EMF and current sources? First for EMF. Vector of voltage sources for EMF. If EMF is in the branch direction, write with the plus sign. If it goes in opposite direction, write it with the minus sign. Just put them in a simple table. For my case, 1, 2, 3, 4, 5. This is 1, this is 3, yeah, this will be 4. For example, let's assume what E1 is 100 volts, E2 200 and so on. What do we see in branch number 1? It's E2, yeah? Yeah. 200 volts and with the plus sign. Branch number 2, 1 and you see in opposite direction. Minus 100. E3, 0. Number 4 has minus 400, so minus 4. And 5, E3 with the plus. Easy. Easy. More complex approach. Current source is a trick thing, so more complex approach is needed when we deal with the current source. Can I erase this? No questions? Yeah, take a picture. Oh, I got two current sources. One is 5 amps and second one is 7 amps. What should I do? There are two possibilities, two vectors for current source. One is called I. It's conducted by node, and if current source inflows into, this will be my node, I should write it with the plus sign. If it flows from the node, I will write it with the minus sign. Easy. Easy. For my network, can I erase? Wait, take pictures. So for my network, it will be easy. 1, 2, 3. Current sources. Node 1, what do we see? First current source inflows, second one outflows. So it will be 5 minus 7. second node inflow 7 and node 3 0. For power flow, this will be used, it's a best solution way for power flows using a current source. We will use this thing. There is other technique. Other technique is idea of additional contour or what's the idea? Assume a current path for each current source. It should be one or more branch. We need to create artificial contour for this current source. This one and for I assume a set of branches forming a contour where this current source current will circulate. It's assumption that this current flows only, so current from this current source flows only in this set of branches. Yeah. J. This supplemental or additional or artificial or imaginable contour vector. In your version of the techniques, what was named for that? You have this idea in your version of techniques theory. Should be.
Vector related,
This representation of current sources.
yeah.
With this artificial, when you set let's say imaginable path for the current of current source.
I sine and I cos. Sorry.
Yeah.
Okay, we display the vector component in cos
Yeah.
theta and sine theta. Yeah.
Okay, let's see. Rule is very simple. If this imaginable current flows in direction of your branch, write it as a plus. If it flows opposite to your branch direction, write it with a minus sign. And here are branches. This technique, very popular in theory, extremely rarely used in reality. There is a group of scholars which stick to this, or some kind of derived from these techniques. It's hard to automate. Sometimes it's used. Can I erase?
Yeah.
You have your picture. Now what we will get? 1, 2, 3, 4, 5. branch 1, no additional current. Branch 2, 5 amp and the plus sign. Branch 3, minus 7 amps. It's about LED. Branch 4, no additional current, and branch 5, 1, so it will be 5 amps. Yeah, here conductor. It can be proved. I will skip small time. M multiplied by G yields an I. Watt time, VV. Second World War time, circuit break for 25 amps. Bulletproof thing. Yeah, bam. You know what I can write now? Base of the bases in electrotechnics. What means KCL? Kirchhoff's current law, first Kirchhoff law. Sum of current in any node is equal. So, sum of current is equal to 0, meaning for us, M, here, one moment. I need to write IB, which are branch current. Yeah? Please forgive me. I will often use automated this. Z means zar. It's in Latvian. Branch in Latvian is zar. Zar, Strauss means branch current. It's hard to teach an old monk new tricks to old monk. So I will on reflex sometimes write zar, Strauss. It means branch current.
It's normal Z, right?
Yeah, it's normal Z from Latvian zars. Zars means branch in Latvian. I. Here is first Kirchhoff law or Kirchhoff current law. In any node where Strauss avots ir current source. Strauss avots means current source. Current source, Strauss avots. Strauss means current, avots source. You should have terminology course for one KP. So current, sum of current in any node equals to 0. And here is Kirchhoff current law. M matrix, in fact, is a first or Kirchhoff current law. But can I solve network with Kirchhoff current law? Yeah, real. How many unknown variables will I get for this network? On the first look, as many as currents, yeah? But How many equations do I have in first current, in first Kirchhoff current law? Node, number of nodes. The problem, I need more equations. And somehow I need to account resistance. I don't have, yeah, you saw what? I don't have any resistance in the previous. I had only topology and current sources. Yeah. Resistance. To work them, I need a square matrix. But for DC network, now I deal with the DC network, this matrix will be diagonal. I will need R here of small r, and this small r is a resistance vector. It's conducted by branches, and it will simple R1, R2, R, Z. ZS in Latin, Zaruskaits, number of branches. Of number of ZS Zaruskaits, number of branches. Zars is branch, skites, number. Resistance, 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 resistance. To make it easy, R1 will be 10 ohms, R2 will be 20 ohms, R3, and so on. And 1, and 2, and 3, and 4, and 5. My tiny R. So what I have created, first branch R5. 5, 0, because it's an R5. Second one, R1, 10 ohm, R1. Third, R2, so it's 20. 4, it's an R3. And 5, R4, so here is a vector of resistance. All resistance are accounted. Complete resistance matrix has a structure, main diagonal, ohm branch resistance, and other elements are mutual. When we will speak AC network, it's think like mutual induction, magnetic coupling. So magnetic coupling is represented as mutual resistance. So if I have 1, 2 net branch, elements of matrix 1, 2 and 2, 1 will be equal, and they will represent a magnetic coupling between branches. Coil, coil, common magnetic field. I have this, I have everything except contours. Kirchhoff voltage law. Sounds like sum of voltage drop in any closed contour equals to 0. What is voltage drop, what is contour, and why it's closed? Voltmeter test leads. I can measure here, I can measure here, I can measure here, I can measure here. This will be voltage drops between. But what is closed contour? Sum of voltage drop in the closed contour. What is closed contour? What is closed contour? My network consists of branches. If someone, I don't know, Maxwell Demon, or someone like student, will take a tree. If the set of branches makes a closed loop, so our traveler can return to the start point. It's the loop is closed. It means what we look at a closed contour. So contour here, contour is a set of branches creating a closed loop or round travel route. If imaginable traveler can return to the start point, it's a closed loop. What this thing form? Oh yeah. Actually, it can be represented as a set of contours. It's a power supply. Or reflection of my memories. No, it's not. It's simple. Really. I can create much more crazy networks. Okay, where we are? What can I select contours here? This one, loop, this one, loop, like this, loop. And now question. Many of them, should I write a Kirchhoff voltage law for any of them? No. It's much bit too complex. I need a look deeper. And deeper is idea of independent contour. Dependent and independent. What it means? Some contour sits on chain and other one runs free. What means independent contour? What means contour dependence? How can contour be dependent? Contour itself is something abstract. This network never exists in reality. It's only my fantasy. Round tree, okay, maybe it's round tree. And what means dependent tree? Okay, let's take a look. We need to look, take a small, let's say, small insight into special area of math science called the graph theory. What's the graph? I can draw a schematic, kind of skeleton schematic for my network. 1, 2, 3. Okay, branch 1, branch 3, branch 2, branch 4 and this way branch 5. This is graph. It's a kind of skeleton schematic of my network. Graph. It's an idea how nodes are interconnected. If you take a base, for example, for city map, yeah, something like this, or the flow chart of organization, who's reporting to who, project management, they all can be represented with some kind of diagram. Who is cooking who is blaming who, and so on. Here, okay, this is graph of my network. They are connected graph and disconnected. In Latvian, saistīts. It's like connected or linked. What means connected and not connected? If any node is reachable from the base node, we have connected graph. If we have islands, for example, some part not reachable from the base node, this one is not connected. It is not possible to solve network represented with a set of islands. Okay, it's possible, but it's a kind of hell, because voltages will problem. If we have a disconnected part, voltages in the island, they will be correct by magnitude, but they can take any angle. Solution for this part will be multiplied by a power yod alpha, where alpha is from minus infinity to infinity. It's not solvable. In reality, you will get not exact solution, but kind of space, kind of cloud of solutions. They all are possible. It is not a good idea solving not connected network. What about this one? Why I'm starting to talk about connected or joint graphs? There is an idea called graph tree. Graph tree is a minimal set of branches to maintain a graph connected. For my case, if, for example, I discontinue this branch, still connected. You can say that all nodes still have voltage. I can disconnect this one, and graph is still connected. So can I eliminate more? No, I can't. This is minimal set. So minimal set of branches to maintain connectivity. Can I create more trees? For this is tree 1. Okay, what can I do? 1, 2, 3. Or this is alternative. Still connected? Still connected. Or something like 1, 2, 3. Or another one. Idea with 3. So 3 is a minimal set of branches to keep the graph connected. To keep my graph connected. And here is one important moment. Actually, this graph represents some kind of some form of schematic, some reduced schematic. This schematic can be described with all first incidence matrix M of, and this matrix will be squared. This meaning what M of is alpha equals to I is a solvable system. This matrix can be inverted. It's a square, well-defined matrix. So, is M alpha inverse this small white equation the small white equation tells me what current in white branch are dependent. The only independent one are orange. What I mark with orange cross. This interconnected or chords. Chord branch or let's say difference of branch between tree and full schematic. When I created tree, I removed chords. So here white are 3 elements and in orange chord. Only chord currents are independent. Actually, in ideal version of the word, to solve network, I only need an equation for these 2 branches. In ideal world, I only need to solve this and this. Because this part is actually solvable with one matrix inversion. Why I'm speaking about contours? I need Kirchhoff current law equation to get a solvable equation system. How should I select contours? I will select my contours to tackle or to get this and this current. The only thing I really need. So my independent contours, let's say A and B, I need to create or select contours to get this and this, to hold the currents. Only independent currents in all this tricky thing. Mu, cyclomatic number, is number of branches minus number of nodes, or number of columns in M matrix minus number of rows in N matrix. To get solvable system, I need a square matrix. So I need lower part for my system, and this lower part should contain as much rows as I need to get a square matrix, meaning number of columns minus number of rows in M matrix. Number of free contours or independent contours in this system. Number of chords. Here, full network, 5 branches, yeah? 3 white lines, 1, 2, 3. 3 minus 2 means 2 independent.
Why those two are only the independent? Why others?
Because for, again, M alpha representing 3 interconnection is square and positive defined. This means what it can be inverted. You know this idea of inverse matrix? There is no division operation in the matrix world. But let's say A multiplied by its inversion yields an unity matrix. Full topology for this network is not invertible. But matrix for the tree, for this, let's say, skeleton, is invertible. It can be inverted, and this means what? 3 currents are not independent, in fact. Only difference between tree and full schematic. Okay, here I can set my second contour, and here contour number 1. I need to select walk around direction, just to be in order. And I will write a matrix. It's actually first incidence matrix, or M, is a matrix for the Kirchhoff current law. This and also B, also P, also known as is a matrix for the Kirchhoff voltage law. Its rate here will be contour, column name is branch, if correspond right +1, it goes in opposite direction, right -1. No connection, 0.
If we stop, so time is over. Shall we go?
1 second. I will create fast my matrix. Why it's over? It's over in 55, not in 50. I have 5 more minutes. Or 1, 2, 3, 4, 5, A and B. Also this repair guide steal a bit of our time. Matrix for Kirchhoff voltage law. A contour, first branch 1. Here will be 0. Second branch A 1, B -1. Third branch B 1. Number 4 B 1, 0, and number 5 A 1, 0. Here it is. You can take a picture if you want. Now, Kirchhoff voltage law. Kirchhoff voltage law will be written as M L and A. matrix branch nodes. This one is the diag of my small R vector. It's a resistance matrix. Branch currents, EMF vector. Complete system. Okay, branch currents equals to I and A. The upper part is a Kirchhoff current law. The lower part is a Kirchhoff voltage law. The thing you see is a so-called system state equation. If you solve it, you will get all branch currents. Something familiar? Had you something like this in your course of electrotechnics? Should be somewhere 3 years ago. No? Guys, what happens in your school?
It was COVID and we studied.
Oh yeah, COVID.
And we studied everything online.
So, I also work online. I danced like a demon ballerina. COVID. So what, COVID? COVID. It's the very basics of our business. Every scholar of electrotechnics teach something, in some form combination of Kirchhoff's law. Believe me, no one really goes this way because it takes most computation efforts. Computation burden for this way is highest. Only insane will go this way. In our business, just for understanding, simplest solutions, simplest networks without any trick will take approximately 2/3 of n cubed of mass operation to solve it. Here, n number of elements equals to number of branches. It's a matrix. I can tell number of branches exactly, but I can tell you one thing. Model of power system to solve a Baltic region and corresponding Europe has 16,800 nodes. And use a power free, and you will get number of mass operation. It's insane. Okay. Do you need an attendance chart? One question. You need to fill it.
No.
Okay. I can end